4.1 goes over solving systems by graphing and substitution. The first part that we're going to look at is to determine whether or not a given ordered pair is the solution for the system. So if you look at example 1, we're given the ordered pair 2, 5. We have the system x plus y is equal to 7, and 3x plus 5y is equal to negative 19. In order for this ordered pair of 2, 5 to be a solution, you have to plug it into both of these equations to get true statements for both. If you only get a true statement for one and not the other, it's not a solution. So you have to make sure that you have true statements for both equations when you plug in these numbers. So we're going to have to plug in that 2 for x, that 5 for y. For the first equation, you're going to have 2 plus 5 is equal to 7. The 2 plus 5 is 7. 7 is equal to 7. So yes, that one works. Try the other equation. You have 3 times x, which is 2, plus 5 times y, which is 5, is equal to negative 19. The 3 times 2 gives us 6. The 5 times 5 gives us 25. When we add these two, the 6 plus 25 gives us 31 is equal to negative 19. In this case, this one does not give you a true statement, so 2, 5 is not a solution. For example 2, we're given the ordered pair of negative 3, 6, and given the system y is equal to negative 2x and y minus 3x is equal to 14. So my x is my negative 3, my y is my 6. I'm going to plug in these values to both of these equations and see if I get true statements. So with the top one, that y is equal to negative 2 times x. We're going to have 6 is equal to negative 2 times negative 3. The negative 2 times negative 3 is 6. 6 is equal to 6, so this one works. Try the other. You have y minus 3x is equal to 14. So that's going to give us 6 minus 3 times negative 3 is equal to 14. The negative 3 times negative 3 is 9. So 6 plus 9 is equal to 14. That 6 plus 9 is 15. 15 is not equal to 14. So in this case, that negative 3, 6 is not a solution. Both of them have to be a true statement in order for you to have a solution. If we look at another example, we are now going to be solving these by graphing. When we graph these, the first thing we want to do is make sure the equations that are given to us are in slope-intercept form. It's going to be the easiest way to graph these. Once you do that, and you graph those two lines on the same coordinate plane, you're going to look for the ordered pair where these two lines cross at. Where the intersection of these two lines is going to be your solution. So if we look at the first equation that we have here, we have y is equal to x plus 2. That's in slope-intercept form. So the only thing we have to do is identify that slope and that y-intercept, plot the y-intercept, and use our slope to get the next points. In this case, our y-intercept is that b value, which is 2. So that gives us 0, 2 as our first point. From there, our slope is 1, so we're going to go up 1 to the right 1, up 1 to the right 1. And we're going to continue this to go through the entire coordinate plane to draw our line through these points. Now, the reason why I do this and I extend these points throughout the entire coordinate plane is so that way I can make sure that the lines where they cross are giving me a specific ordered pair. For that second equation, we have x plus y is equal to 4. This is not in slope-intercept form. So put it into slope-intercept form and solve for y by subtracting that x from each side. So that way it's much easier for you to graph. So with this one, we have a y-intercept or a b value of 4, which gives us that ordered pair 0, 4. So that's going to be here. And we have a slope of -1. So we're going to go down 1 to the right 1. Down and to the right, down to the right. I'm also going to go up 1 to the left 1 to get the points that are on the left side of that point, that y-intercept. And then I can draw my line through these points. The ordered pair, that's my solution, is where these two lines intersect. So if you see here, this ordered pair right here, which is the ordered pair 1, 3, is where these two lines cross at. That's going to be my solution. You can always check your solution by plugging in that ordered pair into the original equations that they give you and see if you get true statements, just like we did with the section before this. If we look at example 3, we have 2 times x plus 2, 2 times y plus 2 is equal to x, and x minus 2y is equal to 4. I'm going to take that first equation, which is 2 times y plus 2 is equal to x. And I'm going to distribute that 2 to get 2y plus 4 is equal to x. I still want to get my y by itself, so I'm going to start this one by subtracting that 4 from each side. I have 2y is equal to x minus 4, and then I divide each side by 2, which means I divide each term by that 2 to get y is equal to 1/2 x minus 2. So the ordered pair that I'm going to start with is that 0, -2, and then my slope is 1/2. So I'm going to go up 1 to the right 2. So I plot that 0 to -2, then I go up 1 to the right 2. And I keep that trend going the entire way to the left of that first ordered pair that I plotted. I go back to that y-intercept, and I'm going to go opposite now. So instead of going up and to the right, I'm going to go down 1 and to the left 2. And that's going to give me my other side, that left side of that line. From there, I can draw my line through these ordered pairs and then start on my next equation. Alright, so if I start on my next line, that x minus 2y is equal to 4. I'm going to move that x over by subtracting it from each side. We have -2y is equal to -x plus 4. Then we divide each side by that -2, so I'm going to divide each term by that -2. So I have y is equal to a positive 1/2 x minus 2. Now look at what you have here. This equation is the same exact one as the one that we first did. So your line's literally going to go right over that top or that bottom line, that first line that you drew on that coordinate plane. So how many times do these two lines that overlap intersect? Infinitely many. So because they overlap each other and they're literally the same exact lines, every single ordered pair that one line has is going to be a solution to the other line as well. So when this happens, you just have infinitely many solutions. For example 4, we're given 2x minus 3y is equal to 6, and 3y minus 2x is equal to 3. For this one, I'm going to solve that top one first. So 2x minus 3y is equal to 6. I'm going to solve that for y. So I'm going to move that 2x over by subtracting it from each side. I get -3y is equal to -2x plus 6. From here, I'm just going to divide each side by 3, so I'm going to divide every term by that -3. And I get y is equal to 2 over 3x minus 2. You got a negative divided by a negative, so it's going to be that positive 2/3. That 6 divided by that -3, they're opposite signs, so that's why that 2 is negative. So this is going to be an ordered pair of 0, -2 for my y-intercept and a slope of 2/3. So 0, -2. From there, I'm going to go up 2 to the right 3. And then keep that trend going the entire way through that coordinate plane. I'm also going to go down 2 and to the left 3. And then I'm going to draw that line through those ordered pairs. From here, I'm going to take that 3y minus 2x is equal to 3, and I'm going to solve it for y. So I'm going to move that 2x over by adding it to both sides. We have 3y is equal to 2x plus 3. Then we divide each side by that 3. So we get y is equal to 2/3 x plus 1. So I'm going to have that ordered pair of 0, 1 with a slope of 2/3. You'll see here that that slope is the same. So when you have the same slope, you have parallel lines, which means they will never intersect. So even if you graphed this line up 2 to the right 3, down 2 to the left 3, these two lines will never intersect one another. So because they never intersect, you have no solution here. So when we solve by substitution, we're going to be given two equations like we were with graphing. However, with one of those equations, either you're going to be solving for a variable or that variable is already going to be solved for. If we look at example 5, we have y is equal to 2x minus 3 and y is equal to x plus 5. Both of these equations are solved for y. So since they are both equal to y, y is equal to y, that 2x minus 3 is going to be equal to that x plus 5. So we can take these two parts and set them equal to one another. So we're just going to have 2x minus 3 is equal to x plus 5. We can solve for the x. Once we solve for x, we can just plug it in for one of these original equations and solve for the y. So in order to solve for x for this, I'm going to move this x over by subtracting it from each side. I'm going to have x minus 3 is equal to 5. And then I'm just going to add the 3 to each side to get that x is equal to 8. Now I can choose either the top or the bottom original equation to solve for y. To me, the bottom one is easier, so I'm going to do y is equal to 8 plus 5. That 8 plus 5 is 13, so I have a y of 13. If x is equal to 8 and y is equal to 13, this gives me the ordered pair 8, 13, which is our solution. If we look at our next example, we have 2x plus 3y is equal to 8 and y plus 2x is equal to 6. Neither of these equations have one of those variables that are solved for, so I'm going to choose one of them to solve for either the x or the y. To me, the bottom one is going to be the easiest because I have a coefficient on that y of an invisible 1. So I'm going to take that y plus 2x is equal to 6, and I'm going to solve this entire equation for y. So I'm going to get y by itself. By doing this, I'm going to subtract each side with that 2x. So we have y is equal to negative 2x plus 6. Now that I have what y is equal to, I'm going to take that expression, that negative 2x plus 6, and plug it in for y in the opposite equation. So I'm going to take that 2x plus 3 times y, which is negative 2x plus 6, is equal to 8. And for this one, I'm going to distribute that 3 and solve for that x. So I'm going to have 2x minus 6x plus 18 is equal to 8. I'm going to combine my like terms. The 2x minus 6x gives me a negative 4x plus 18 is equal to 8. From here, I'm going to subtract that 18 from each side. I have negative 4x is equal to negative 10. And then we're going to divide each side by that negative 4 to get x by itself. And we have that x is equal to a positive, because a negative divided by a negative is a positive. The 10 over 4 simplifies to be 5 over 2. From here, I'm going to plug this in for x. I can use that equation that I solved for y, so that way now I can solve for y. So if I did that, I would have y is equal to negative 2 times 5 over 2 plus 6. The negative 2 times the 5 over 2 is going to be a negative 1 times 5, which is just negative 5 plus 6, which gives us y is equal to 1. So if x is 5 over 2 and y is equal to 1, our solution is 5 over 2, comma 1. For our next example, we have 2x plus 3y is equal to 5 plus x plus 4y, and y is equal to x minus 5. So you can do one of two things here. Since you have y is equal to x minus 5, you can take that x minus 5 and plug it in for everywhere there is a y on that top equation, or you can combine like terms first with that top equation and then plug in that x minus 5 for y. So if I'm going to plug in that x or that y wherever the y is, I would just substitute it in, distribute, combine like terms, get my x by itself. I'm going to combine my like terms in that 2x plus 3y is equal to 5 plus x plus 4y first. So I'm going to subtract the x from each side. This is going to give me x plus 3y is equal to 5 plus 4y. I'm then going to move that 4y over by subtracting it from each side. I could have also added the 3y, subtracted the 3y from each side as well. So I would have x minus y is equal to 5. If y is equal to x minus 5, I'm going to plug this in for y in this equation. So I'm going to have x minus 5 is equal to 5. I'm going to distribute that negative. So I have x minus x plus 5 is equal to 5. The x minus x cancels out, so I just have 5 is equal to 5. That is a true statement, so our answer is infinitely many solutions here. For our last example, we have x minus 2y is equal to 3, and 2x minus 4y is equal to 7. Neither of these equations are solved for a variable. So again, I'm going to look for the equation that has a coefficient of 1 in front of one of those variables. That top equation has an x minus 2y is equal to 3. That x has an invisible coefficient of 1, so I'm going to get that x by itself. I'm going to isolate that x. So I'm just going to move that 2y over by adding it to both sides. We get x is equal to 2y plus 3. Because x is equal to 2y plus 3, I'm going to plug this in for x in the opposite equation. So this is going to give me 2 times 2y plus 3 minus 4y is equal to 7. From here, we can distribute that 2. This is going to give us 4y plus 6 minus 4y is equal to 7. That 4y minus 4y cancels out, so we just have 6 is equal to 7. That is not a true statement. It's a false statement, so we have no solution for this one.